This is section 7.1, and we will be talking about applications of right triangles. And to solve a right triangle, we are very familiar with this already. We will be using the Pythagorean theorem, our trig properties, and of course, the sum of all three angles of a triangle must equal 180 degrees. So let's just go ahead and look at number 1, and we can see that they've asked us to solve the right triangle. We will round the lengths of sides to 1 decimal place. So we will be looking for A and B. Now the first thing we'll do is we'll state that B, and of course, B has to equal 180 degrees minus 90 degrees minus 28 degrees. So we're looking for this angle here, and that comes out to 62 degrees. Okay, now we know that the sine of 28 degrees is equal to A over 14.8. That allows us to say that A is equal to 14.8 times the sine of 28 degrees. And you can try that in your calculator. Make sure you are in degree mode. And you should come up with 6.9. We can also say that the sine of 62 degrees is equal to B divided by 14.8. And now we can say that B is equal to 14.8 multiplied by the sine of 62 degrees, and that's approximately 13.1. Okay. Let's look at number 2. We'll be solving this right triangle, and as you notice, this time we're given 2 sides. So we'll first solve for B. So we know that B squared plus 9 squared equals 20 squared. B squared plus 81 equals 400. Subtracting 81 from both sides, we have 319. And let's just go ahead and take the square root of 319. And we get approximately 17.9. Okay. Now, let's take a look at these angles. We only have angle, actually the right angle, angle C. So we will have to find angle B and angle A. So we know that the cosine of angle B is A divided by, 9 divided by 20. So B equals cosine inverse of 9 over 20. So B is approximately 63.3 degrees. Okay, and now that we have 63.3 degrees, now we can say that angle A is about equal to 180 minus 90 degrees minus 63.3 degrees. So A is approximately 26.3 7 degrees. Okay, looking at number 3, we have an applications problem. And we have a surveyor standing on level ground 100 feet from the base of a lighthouse. You know what? Let's go ahead and get that on there. And we have 100 feet. Okay? He measures the angle from the ground to the top of the lighthouse to be 18 degrees. Rounded to the nearest foot, what is the height of the lighthouse? So we're looking for y. So what do you notice? We want to find y, and what we have is adjacent and adjacent side. Okay, so what we would say is if we have an angle and an adjacent side and we need y, we could say that the tangent of 18 degrees is the opposite side over the adjacent. So we could say that y equals 100 multiplied by the tangent of 18 degrees, and y is approximately 32 feet. Okay. In number 4, a surveyor stands on level ground 90 feet from the base of a lighthouse. And he measures the angle from eye level to the top of the lighthouse to be 28 degrees. If the surveyor's eye is 5 feet above the ground, what is the height of the lighthouse? So we are going to be able to find this distance y, and then once we find it, we can add 5 to it. Okay? So what do we have? Well, we want to first find y. And again, we have the adjacent side. So y is opposite, and we have adjacent. So again, we will find the tangent of 28 degrees to be equal to the opposite over the adjacent side. So y is equal to 90 multiplied by the tangent of 28 degrees. So y is approximately 48 feet. So the height of the lighthouse is equal to 48 plus 5 feet, which will equal 53 feet. Okay, in number 5, to determine the height of a window in the top of a lighthouse, 2 measurements are taken from the ground 90 feet above, from the base of a lighthouse. The angle of elevation from the ground to the bottom of the window is 36 degrees. So this is to the bottom of the window. And the angle of elevation from the ground to the top of the window is 42 degrees. Find the height of the window to the nearest foot. So we are looking for this distance right here. And I am going to need to find y1. And then actually I'll go ahead and just match these colors. So this will be y1. And this height will be y2. And then as you can see, that height of that window is going to be y1 minus y2 minus y1. So let's work on the smaller triangle. We could go ahead and just write that down here. And we have tangent. Will we be using tangent again because we have the opposite. And I did not put the 90 feet from the base. This is 90 degrees. 90 feet. Okay. So we have adjacent and opposite. So again, we'll be using tangent. So the tangent of 36 degrees is the opposite over the adjacent. So x is equal to, and I should have used y1 so y1 is equal to 90 multiplied by the tangent of 36 degrees. So y1 is 65.3, and we'll use a few decimals here so we don't have any rounding errors. We'll round once we're finished subtracting. Okay, let's go to the larger triangle. And of course, we have the tangent again, and the tangent of 42 degrees is now y2 divided by 90. So y2 is equal to 90 times the tangent of 42 degrees. And y2 is 81.0364. So now this window measurement is going to equal 81.0364 minus 65.3888, and we come up with 16 feet. Okay, from the given information, can we determine the height of the lighthouse? And that answer is no. And the reason it's no is we do not know this distance right here. So we are not aware of that. We only have the top of the window and the bottom of the window. So this answer is no. Okay, looking at number 6, an observer in a helicopter hovering 200 feet above the sea makes measurements to 2 buoys at points A and B below. And you can see that diagram. And so we can go ahead and at least put 200 feet here. She finds the angles of depression to be 44 degrees and 35 degrees respectively. And respectively means in that same order. So A is 44 and B is 35. Okay. Assuming the observer is in the same vertical plane as the buoys, what is the distance between the two buoys? So what we'll do is we'll have this distance be x1, and we'll let this distance be equal to x2. And the distance between the buoys is going to be equal to x1 plus x2. So let's find each of those individually. Again, we have opposite and we're looking for adjacent. So we will use the tangent for both of those. So we can first say that the tangent of 44 degrees is going to be 200 divided by x1. And let's go ahead and write our second equation. The tangent of 35 degrees is going to be 200 divided by x2. So we can say that x1 is equal to 200 multiplied by the tangent of 44 degrees. So x1 is equal to 207 feet. Okay, let's do the same. So now we have x2 is equal to 200 multiplied by the tangent of 35 degrees. So x2 is equal to about 286 feet. And I really should put, because I'm rounding, approximately. So adding these together, we have 207 plus 286, and we come up with 493 feet. Okay. Now, let's take a look at how we will be computing the bearing of an object. So the term bearing is used to convey the angular relationship from one point to another. That's bearing. So the bearing from point A to point B is the degree measure of the acute angle formed by ray AB. And that is going to be in the north-south line. So a bearing is denoted by the letter north or south, so N or S, followed by the measure of the angle in degrees, followed by the letter east or west, E or W. Okay, so this is very important. For example, a ship bearing to a south 40 degrees west is heading in a southwesterly direction. Specifically, the ship is traveling 40 degrees to the west of south. And as you can see, west of south. So we're going west of south. So let's try number 7. Find the bearing from A to B. So what we have here is this angle right here is 90 minus 40 degrees. So that's going to be equal to 50 degrees. So now we will be north 50 degrees east. So mainly we're going east 50 degrees coming from the north. Okay. Looking at number 8, as you can see, this angle right here is going to be 124 degrees minus 90. This angle is what we want. And that angle is 124 degrees minus 90 degrees, and that's equal to 34 degrees. So we are coming from the west, so we will be north for 34 degrees west. Actually, starting at north, we're moving this way west. Okay. Okay. In number 9, if you can kind of initially see, let's talk about what this will be when we're finished. We're going to be going in this direction towards south. So we'll be coming, or we will be moving west from south. Okay, let's kind of take a look at this. This is here. We are moving east from north. That's correct. And here we are moving west from north. Good. And we are moving west from north. Okay. Probably didn't explain that very good. So we are going to be moving west from south. So we know in number 9 that we are going to have south, and whatever this degrees is right here, and then that's going to be west. Okay, so how are we going to find that angle? This angle right here is going to be 270 degrees minus 220 degrees. And that's how we come up with this angle to be 50 degrees. So we are south 50 degrees west. Okay. In number 10, let's do what we did before. We are going to be moving east a certain angle from south. Okay, so we are going to have south and east. So now to come up with this angle right here, which is what we need, that is just 90 minus 19 degrees. And that's 71 degrees. So we're south 71 degrees east. Okay, now let's take a look at number 11. We're asked to find the bearing from A to B. So we could actually draw this little 4 quadrants you could think of, and this is the angle that we are looking for. So moving over to this sketch, we can see that we would like this angle right here. Now, as you can see here, if this angle is 30, then this angle is also 30. So the angle that we would like is 90 minus 30, and that's equal to 60 degrees. Now, we are moving west from south. So this would be south 60 degrees west. Okay, let's take a look at number 12. A boat leaves a marina and sails north for 30 minutes and then west for 2 hours. If the boat's average speed is 12 miles per hour, find the bearing for the return trip. Okay, we will be rounding to the nearest degree. So let's just draw a little sketch here, kind of see what we're looking at. Okay, so a boat leaves a marina and it sails north for 30 minutes. and then it sails west for 2 hours. Okay, so let's take a look. How could we come up with distances in this case? So let's take a look at this. We have 2 hours, and then we have 12 miles per hour, and that gives us 24 miles. So this distance must be 24 miles. And let's do the same thing for the 30 minutes. We have 1/2 of an hour multiplied by 12 miles per hour, and we come up with 6 miles. Okay, so now we have a triangle. We can draw it on a new set axes where we can come up with our triangle. And so we have 6, 24, and now we can actually create a new little set of axes here. And actually I can dash them in. Maybe I should make them a little bit brighter. And so now we have this triangle, and we can come like this. And now this is theta. So let's go ahead and try to come up with theta. So we have the tangent of theta is 6 divided by 24. So theta equals tan inverse of 6 over 24, which is about equal to 14 degrees. So now what we want to do is maybe make this picture even larger. So if we have these same axes, and then we can see that we have 14 degrees here. Now we are looking for this angle right here, because this angle will be east of south, and that angle is 90 minus 14 degrees, and we come up with 76 degrees. So we have south 76 degrees east. Okay, and looking at number 13, we have a plane leaves an airport at a bearing of north 38 degrees west and travels 280 miles for 2 hours. And the plane then makes a 90-degree left turn and travels 500 miles to its destination. And we will be looking for the bearing required to locate the plane from the airport. And we will round to the nearest degree. So we definitely need a nice sketch here. And what we have is well, let's look at this. We have 280 miles per hour. And we're going to travel, or the plane traveled for 2 hours. And that would be at a bearing of 38 degrees west of north. So if we have 280 miles per hour times 2 hours, we have 560 miles. And that is this distance right here. Now, we are going to the plane makes a 90-degree left turn and then travels 500 miles to its destination. Okay, and so now we want to find the bearing required to locate the plane from the airport. So in order to do that, we will be looking for, the angle we need going west of north. So we need to know what this angle is going west of north. So that means once we find this angle, we will add those together to see what this angle is. And actually, I can always just do that in. So we want this angle. So we will be going west from north, okay? So let's go ahead and first find theta. And so we have that the tangent of theta is 500 divided by 560. So we know that theta is equal to the tan inverse of 500 divided by 560. So theta is about 42 degrees. Okay, so now what do we need? We are going to take 38 degrees and add 42 degrees, and we will come up with 80 degrees. So we are north 80 degrees west. And that concludes this section.